All right, welcome to the Algebra 2 Review Solutions. Make sure that you've tried these first on your own, and then when you go through this, you can give yourself a score to see where you're at, and then also plan, have some questions that you're ready to ask, and also plan some areas in which you want to study further. All right, pretty straightforward here. I want to prove that this is an odd function since both of the degrees are odd. I know it's going to be odd. I want to prove that. So I know that that means negative f of x will equal f of negative x. So I need to show that this is true. So I'll go ahead and set this up, find each, see that they are equal, and so negative f of x is equal to f of negative x. Therefore, f of x is odd. Each of these steps, so this, if I have this step and set these up, that's 2.5, and then if I get this step, it's a 3, and then if I finally get to the final step, it's a 3, 5, and a 4 plus if I write it out correctly. So on and so forth. For part B, I need to sketch the graph of this function, so I need the end behaviors. That's easy since this is a odd degree polynomial with a positive leading coefficient, increase to the right, decrease to the left. Now I look for the roots. I can factor this easily, and factored form is going to allow me to set it equal to 0 and solve. So I have two factors, and one of them is very clearly going to be made 0 when x is 0. This will never be 0 because anything squared is positive. Plus 1 will always be positive. So I'm going to have one real root, and that makes this pretty easy to sketch as such. Right here I'm finding the average rate of change. It's important to remember that the average rate of change is essentially the slope between the 2 points. So my points are at 0 and 20. And so I need to find the slope between these 2 points. In other words, I need to find the change in y, f of b minus f of a, divided by b minus a. And my a value here is going to be 0, my b value is 20, and I can approximate the value of my function at those points, as I've done here. Go ahead and set this up, solve through. Notice that the numerator represents animals, the denominator represents days, so this is going to be animals per day. And then this means that over the first 20 days of the month, 5 animals entered the shelter each day on average. And each of these is very important. I need to say that this is each day and that it's on average. You could also say that over the first 20 days of the month, approximately 5 animals, or the number of animals in the shelter increased by approximately 5 per day on average. Remember, this is not actually how much it's increasing by per day. This is an average. All right, fourth degree polynomials, fifth degree polynomials. Here I just need to remember that imaginary roots have to come in pairs. That's what we've seen when we studied quadratic functions. So these are the possibilities for fourth degree, and these are the possibilities for a fifth degree. And what I notice is that this fifth degree, it has to have at least one real root, and that's going to be the case no matter what the degree is, if it's odd. So that's an important thing to remember, and just in general to keep with you whenever you're looking at an odd degree polynomial. Alright, so here I can see that I'm going to write an equation because I'm solving for some value that I don't know, so that's important. I want to find this value such that x minus 1 is a factor of this function. I label this so I can refer to it. Now the factor theorem says that if x equals 1 is a root, then x minus 1 is a factor. And it says the opposite as well, that if x minus 1 is a factor, then x equals 1 is a root. And so if x minus 1 is a factor, then I know x equals 1 is a root, and so that'll allow me to set up an equation. That means that f of 1 is equal to 0. That's the key thing to take away. And so this equation will include a, since it has my function evaluated at 1, and I can use that to then solve for a, which is going to be 7. Alright, here I'm dealing with a sum of two functions. So the function s is f plus g. And what I remember is, this is actually a simple question because I'm just looking at the value of g and adding the value of f to it. So when I'm looking at the graphical representation, it's particularly easy. Consider the x value 0. So s of 0 is going to be f of 0 plus g of 0. Well, f of 0 is 1, g of 0 is 4, and 4 plus 1 is 5. So that's what my function s is going to be when x is 0. So I can do this for each point. Starting at -4, I can see that g is maybe 1/4, and f is -1, and so really what I'm doing is I'm thinking, okay, which value is bigger, the negative or the positive value? And the negative value is bigger, so it's still going to be negative, and it's just going to increase by this amount here. Same thing here, it looks like this negative value is a little bigger, and so I'm going to increase by a little bit, but not all the way to 0. Here, f of x is 0, so I'm adding nothing to whatever g of x is, so it stays at whatever g of x is. Here, f of x is about a half, and so I'm adding a half to whatever g of x is. Here, we did this point. Over here at x equals 1, I'm adding about 1.5 to whatever g of x is. Here I'm adding a little less than 1 to whatever g of x is. Here I'm adding, a little less than a half to whatever g of x is, maybe a half you want. Here I'm adding just very, very little to whatever g of x is. And so plotting these points, I can then sketch my curve. All right, here I'm looking to show that x plus 2 is a factor of f of x. This boils down to me showing that -2 is a root. That's what the factor theorem tells me. So I plug in -2 into my function, and I get a y value or an output of 0. So x equals -2 is a factor. X equals -2 is a root, and by the factor theorem, x plus 2 is a factor. How many factors will it have? Well, it has to have 3 roots since it's a third-degree polynomial. That's what the fundamental theorem tells me. So that means that there's going to have 3 linear factors since each root gives me a linear factor. I want to write f of x in factored form. So I have one factor. I need to know what the other factor is going to be. In other words, what times x plus 2 will give me my original function. So I do polynomial division. I get 4x squared plus 36. So my function is x plus 2 times 4x squared plus 36. I look to factor this out. I'm going to pull out a 4. And I can use the quadratic formula by setting this equal to 0 to solve for the 2 roots of this. And that will allow me to write the 2 factors. Now I should notice that this is always going to be positive, since x squared will always be positive, and this is a positive number. So I should realize I'm going to get a couple of imaginary roots, and here I get roots of -3i and positive 3i, which gives me x plus 3i and x minus 3i. And then I can go ahead and sketch the function. I know it has a root at -2. These are imaginary roots. It's a third degree, so it has opposite end behavior, increasing to the right, decreasing to the left. Alright, so here I want to prove that the product, multiplication, of 3 consecutive odd integers is equal to n cubed plus 6n squared plus 8n, where n is the smallest odd integer. So I know that if n is the smallest odd integer, then 3 consecutive odd integers will be n plus 2, and n plus 4, and I'm multiplying them together. So I want to prove that this is going to equal this. So I need to start with this and work my way through. I multiply these together and then distribute the n in and get n cubed plus 6n squared plus 8n. So therefore, 3 odd integers multiplied together is equal to n cubed plus 6n squared plus 8n. I want to create a right triangle where the hypotenuse is at least 200 units greater than the shortest side. So by the Pythagorean polynomial identity that we proved, we know that if we pick any 2 positive integers where m is greater than n, then the 3 side lengths of my right triangle will be given by m squared plus n squared minus n squared, and 2mn. And I know that I want the hypotenuse to be a heck of a lot greater than the smallest side. So looking at these values, I can sort of see that this could be, pretty small. I could also make this pretty small. And I just decided to try and make this fairly small. So I know that if I have a very small n value, like 1 or 2, then this won't get too big. So I need to make m big enough that this is going to be a pretty big value, but n small enough that this will be at least 200 units less than my hypotenuse. So I chose 21, and that happened to work out. I get 401, 399, and 40, and that's a right triangle, since I've already proven that these form the side lengths of a right triangle. Alright, for each of these I need to use the summation form of the binomial theorem to write this out, then expand and simplify. Not a whole lot to talk about here. Just make sure that you are familiar with the binomial theorem and that you can compute 4 choose, whatever, 3 choose whatever, either with Pascal's triangle or hopefully using factorials, since, as you'll see in the next question, you might want to use those instead of Pascal's triangle. What is the coefficient of the x to the 7th term for x plus 3 to the 10th? So here I noticed that I don't want to go through and write out the whole expansion. I want to be able to skip ahead to the x to the 7th term. So by writing my expansion, x plus 3 to the 10th, in summation form, I can clearly see that I'll have x to the 7th when k is 3. So when k is 3, I'll have 10 choose 3, x to the 10 minus 3, which is x to the 7th, 3 cubed. 10 choose 3 is, I think, 120, and 3 cubed is 27. Multiply those together, you get 3,240, and so that's going to be the coefficient of my x to the 7th term. What is meant by 10 choose 2? Well, quite simply, it's how many ways can I choose 2 things from a group of 10. So come up with your own question here. I came up with my own. Of course, we've talked about the candy candy bar example that I like to use a lot, but I encourage you to come up with a couple of different ones on your own. One that comes to mind is thinking about how you could look at a situation where you're picking shoes out of a certain number of shoes. That might be an interesting one to think about.